Good day, everyone. My name is Patricia Ann Saludes de Vera, and I am from BSF 4G1. And for today's video, I am going to discuss about the glow discharges and plasma. And after discussing this lesson, we will learn about how the radio frequency generates to plasma. So let's begin. So, what is a glow discharge? So, a glow discharge is a plasma formed by the passage of electric current through a gas. Analyzing the light produced with spectroscopy can reveal information about the atomic interactions in the gas. So, glow discharges are used in plasma physics and analytical chemistry. In this picture we have here below, this is a picture of a classic glow discharge in a Crookes tube source. This picture here. So, as an additional information, I want you to know that glow discharge or the plasma glows when the glow discharge regime, it owes its name to the fact that the plasma is luminous. When we say luminous, that means that is bright or shining, full of shedding light, especially in the darkness. So the glass glows because the electron energy and number density are high enough to generate visible light by excitation, collisions. This means that the plasma is in contact with only a small part of the cathode surface at low currents. So, for the next part, we have here the direct current glow or the DC glow discharges cathode glow. And this means that this part is our highly luminous layer, or where you can find the excited atoms, secondary electrons, neutralize the incoming discharge ions and positive cathode ions. So I would like to express or give you the idea what is the meaning of the cathode and anode first. For the cathode, this means that this is the negatively charged electrode by which the electrons enter an electrical device. But when we say anode, this is the vice versa of the cathode. Anode is the positively charged electrode by which the electrons leave a device. So as you can see, we have here the figure 3.13, schematics of simplified sputtering system. For the right side, we have the DC or the direct current, and for the left side, we have the RF or the radio frequency. DC and RF are having the same levels of words, but as you can see, in radio frequency, there is an impedance. When we say impedance or matching network, this is the capacitor or inductor that we use or that is needed to ensure the maximum power electricity or power delivery. So, in this part, as you can see, we have also here the picture again of the classical glow discharge in a Crookes tube source. This one here. I would like to elaborate on the parts of it. And first, we have to discuss what is the cathode glow. So, cathode glow means maintained by electrons produced at the cathode by positive ion bombardment. And we have also the cathode Crookes dark phase. This one. This is the shed or where you can see the net positive space charge, low E density. And most of the applied voltage is dropped. Positive gas ions are accelerated toward the cathode. And we have the negative glow. For the negative glow, this one is where the accelerated electrons acquire enough energy to impact ionize the neutral gas molecules. And this black here, we have the substrate or the underlying substance or layer. We have also the Faraday dark space. the Faraday dark space is a dark space of low light intensity between the positive column and the negative glow from the cathode in a vacuum tube. And also, we have the positive column, this long line here. This is what we call a long glowing region, which fills most of the distance between the electrodes. And this part, we have the anode dark space. The anode dark space is where the region between the anode show and the anode in a vacuum tube occurring when the pressure is low. And also, we have the anode glow. So all these thoughts here, or all of these charge effects, stem from the fact that electrons and high ions have such different masses and hence velocities and energies. Okay, again, this is where the cathode, or the part where is the electrons are going to enter in an electrical device. And and in this part is the anode, where the electrons live in the electrical device. Next is we have the ion surface interactions. Of course, we have that sputtering and the ion sputtering, or the ion surface interactions. First, I would like to tell you what is the sputtering. So sputtering means, refers to the removal of material from a target by the impacts of high energy particles. And aside from that, we have the ion sputtering. So what is the difference between the ion sputtering and the sputtering? So when we say ion sputtering, this is a phenomenon where atoms are sputtered from a solid surface when ionized and accelerated. Atoms or molecules hit the solid surface. This phenomenon is utilized for formation of a thin film on a solid surface, specimen coating, and ion etching. So, another picture we have here, the depiction of energetic particle bombardment effects on surfaces and growing fields. We have the near surface region, the surface region, the absorbed species, energetic particle or enhanced surface mobility, the enhanced chemical reactions, sputtered redeposited atoms, energetic particle again, photons, secondary electrons, reflected ions or neutrals. We have also the sputtered ions or atoms, backscattered surface, altered region, and also the collision cascade, the channeling, the trapping, lattice defects, implanted, displacement, recoil implanted. All these things depends on the type of ion or mass or charge, the nature of surface atoms, and ion energy. So, after discussing what is the sputtering or ion sputtering, we have here the sputter yield. We have here the formula how to get the sputter yield. Of course, we have, you have to divide the ejected atoms or molecules over the incident ion. In this part, when you got the answer, this is what we call a measure of efficiency of sputtering. So, these sputter yields values are typically in the range of 0.01 and 4 and increase with the mass of metals and energy of the sputtering gas. Noble sputtering gases with energies of 0.5 kilo electron volt and 1.0 kilo electron volt. So S, from sputtering from collision cascade theory by Sigmund. This one is a theory from Sigmund. This is what we call the cascade theory or collision cascade theory. So this means a measure of the efficiency of momentum transfer in collision. So S, or sputtering from collision cascade theory by Sigmund, we have the sputtering, or S, is equals to 3 alpha over 4 pi squared and 4 m sub 1, m sub 2 over the quantity of m sub 1 plus m sub 2, and we have the E sub 1 over E sub t, and the quantity of E sub 1 lesser than 1 kilo electron volt. And we have the 3.56 alpha over 1 and Z sub 1, Z sub 2 over the C sub 1, 2 to the power of 3 and Z sub 2 to the power of 3 also. And times or multiply it to the M sub 1 over M sub 1 plus M sub 2, we have the Sn or S sub n E over E sub B times the quantity of E sub 1 greater than 1 kilo electron volt. So Sn or T in E, this is the stopping power or a measure of the energy loss per unit length due to nuclear collisions. So what are the sputtering of alloys? This one, we have the thermal evaporation loss of stoichiometry sputtering. Same composition, much greater difference in vapor pressures compared to the difference in sputter yield mass. Homogenized readily due to rapid atomic diffusion and convection effects in the liquid phase. So we have the substrate heating, PCD or pitch circle diameter times the DT over the DT is equals to P minus L. This is equivalent or going through T over T small. Emissivity, epsilon or ellipsis is equals to 0 or 0.9. So for the film deposition rate depends on the sputtering pressure and current variables. When our P goes downward, shed or cathode is wide. And ions are far from target or lost. Electron mean free path upward and then goes to ionization efficiency is low and no plasma below 10 mTOR. And if our P goes upward, our electron mean free path downward and large ion current but sputtered atoms undergo increased scattering, not efficiently deposited. For another one, we have the concept of self-bias at radio frequency electrodes. We have here the figure 3 to 19. This is the formation of pulsating negative shed and capacitively coupled cathode of radio frequency discharge, where A, this one here, is net current or zero self-bias voltage. And when in this B, this is zero current or non-zero self-bias voltage. So we have the concept of self-bias at radio frequency electrodes. This or the disparity in electron and ion mobilities, positively charged electrode draws more E to the negative current but goes through no charge transferred through capacitor. This self-bias voltage or negative at target electrode, capacitively coupled electrode. So for the both electrodes in radio frequency sputtering system should sputter. This causes a contamination in the sputtering field. The ratio of the voltage across the shed at the small capacitively coupled electrode, our VC, to that across the large directly coupled electrode or the VD, including the substrate and chamber walls, etc. is given by V sub C over V sub D is equals to the quantity of A sub B and A sub C to the power of 4, which the fourth here is the power dependence, means large add is very effective in raising the target shed potential while minimizing ion bombardment of grounded fixtures. So, this part is very important because in this part, I would explain how does radio frequency generate plasma. This question answered from my research, it is when an radio frequency current is applied to a planar coil, an oscillating magnetic field or B field is created both above and below it. This generates a primarily azimuthal radio frequency electric field. inside the vacuum chamber, this E field starts an electron avalanche, which creates the plasma. Okay. And this is the example how the radio frequency generate plasma. We have the radio frequency coils, collected rod, to vacuum pump, evacuated chamber, the metal or our metal here, and the HE gas or the helium gas. This is where the helium gas goes. And of course, this disseminate all the things that should be needed. I think that would be all for today. Thank you for listening and God bless everyone. Thank you.